Buster's video training seminars. My name is Charlie, and today we're going to be looking at indoor air quality. Now, indoor air quality is the quality of air in and around buildings and structures. It is frequently associated with the health and comfort of the building's occupants. Here's a little fun fact for you. Did you know that Canadians spend an average of 90% of their time indoors? This is why it is so important to have good indoor air quality. As such, maintaining good indoor air quality is crucial to good health and safety. Homes and offices contain many substances that may be hazardous to our health. When we look at indoor air quality, we look at the indoor air pollutants, and we break them down into two major groups. The first one is minor irritants, such as dust and animal dander. The other one, major irritants, like molds and chemical vapors that may be emitted from building materials and furnishings. In general, indoor air quality contaminants can be divided into two categories. The first, chemical pollutants. The second, biological pollutants. Chemical pollutants are gases and particles that come from combustion appliances, tobacco smoke, household and personal care products, various building materials, and outdoor air. I want you to really remember that one, outdoor air, because later on we're going to explain why this is so important when testing for the indoor air quality of a home. Other pollutants in our home can come from furniture, cabinets, building materials, paint, wallpaper, cleaning products, glues, and some cosmetics, because they emit gases into the indoor air. We call this process off-gassing. Deteriorating building materials can emit dust into the indoor air, and this dust may be toxic if the source material is also toxic. For example, insulating materials containing asbestos or paint containing lead can release dust particles into the air and expose people to those substances. See, pollutants from household products and building materials commonly found in Canada include asbestos, formaldehyde, and lead. Gas stoves, fireplaces, and furnaces produces carbon monoxide, nitrogen dioxide, and small airborne particles called particulate matter. All of these can increase the level of pollution in your indoor air and negatively affect your health. Pollutants from combustion appliances can include carbon monoxide, nitrogen dioxide, and wood smoke. Now, biological pollutants. Biological pollutants are living organisms like mold, bacteria, and dust mites. Some other common indoor biological contaminants include volatile organic compounds, or VOCs, pollen, viruses, insects, and insect fecal matter. Now, mold is one of the most common biological or indoor air pollutants. The importance of mold as an indoor air pollutant has grown significantly in recent years. North American and European studies show a relationship between mold and an increase in the following symptoms: eye, nose, and throat irritations, coughing and phlegm buildup, wheezing and shortness of breath, and allergic reactions. Although mold can worsen the symptoms of asthma, it is still unclear whether or not it can actually cause asthma in healthy people. Now, poor indoor air quality has also been linked to sick building syndrome, which is a combination of symptoms thought to be caused by the environment in which a person lives or works. Several factors play a role in the maintenance of good indoor air quality. 1. Moisture control. 2. Proper ventilation. 3. Air exchange. And 4. Cleanliness. Now, moisture control is eliminating and repairing sources of moisture to reduce relative humidity inside of the home. See, mold thrives in damp environments. Wherever there is a moisture problem, there is likely a mold problem. It takes around 24 to 48 hours for mold to multiply after a water intrusion. Most mold problems are therefore the result of moisture problems, and these problems come from leaky pipes and roofs, flooded basements, cracks in walls and foundations, and also everyday activities like cooking, washing and drying, and showering. See, if a home does not have an effective ventilation system in place, the potential for both mold growth and poor indoor air quality increases. A lack of ventilation, especially in newer airtight buildings, is a key factor that impacts the quality of indoor air. Because newer homes are built to be airtight, they are particularly vulnerable to air quality problems. See, in an attempt to save energy and lower energy costs, we have changed our building methods. Building enclosures are now twice as tight as those built 20 years ago. This tightness is linked to new building materials like Tyvek, which is a house wrapper of vapor barrier, thermal insulation, thermal pane windows, and precast panels. All this is great, but it results in lower exchange of air between interior conditioned spaces and the exterior. Finally, this lessens the dilution of moisture and harmful interior pollutants such as formaldehyde, VOCs, radon, and carbon dioxide. The quality of indoor air is influenced both by the quality of outdoor air and by the indoor sources of emission. In almost all inhabited enclosed spaces, there is a continuous exchange of air with the outside. Therefore, all contaminants of outdoor air are likely to be present inside. This is why, when performing air quality tests, it is important to take at least 2 tests. One test indoors to test the suspected area, and one test outside. This acts as a control group against which we will compare those indoor results. Construction issues. Building materials, assemblies, features, and processes have changed drastically over time. These changes significantly affect the air movement and moisture processes that occur in our homes and offices. See, today we are also building in areas that were previously considered undesirable, like wetlands, floodplains, and areas with high water tables. We are also building with different materials. Plywood and OSB, which is oriented strand board, absorb water up to 5 times faster than conventional lumber. Drywall fosters mold growth much better than plaster. And thermal insulation does not allow wall cavities to dry out after a water intrusion. Loss of active chimneys. Active chimneys decrease mold concentrations in the indoor breathable airspace. Active chimneys also act as exhaust fans, extracting large quantities of air from conditioned living spaces. Forced HVAC systems are usually constructed with numerous supply duct systems and one common leaky return duct. This system leads to constant pressurization and depressurization within the tighter building envelopes. The system creates what we call negative pressure. This negative pressure draws moisture, radon, pesticides, and soil gas from the foundation into the building envelope. This system also creates positive pressure. The result is that warm, moisture-laden air that may be pushed into the walls and roof cavities. The warm, moist air in these wall cavities is prevented from drying by thermal insulation. And here is why you see poor indoor air quality. All of these factors contribute to poor indoor air quality. It is important to have a certified technician come and inspect your home to determine whether or not the indoor air quality of your home or office is good. Remember, we as Canadians spend almost 90% of our time indoors. It is important for us to know that the air that we're breathing is good, healthy, and safe for us, for our employees, and for our families. Thank you very much.